Now, we're going to take up one more problem. Problem number 22. An overhanging beam ABC is loaded as shown in the figure. Draw the SFD and BMD. Also locate the point of counterflexure. Determine positive and negative bending moment. So you can see from A to C, A to B you have a simply supported, and from B and C you have an overhang. So you have an UDL of 2 kilonewton per meter for an entire span of 6 meters, and then at the end you have 2 kilonewton, the point load which is acting. So you can see the support reactions at R, vertical support reactions at RAV and RBV between A and B. Now this A and B has got a 4 meter distance span. So to find out the support reaction, so taking the moments about the point A, which is RBV into 4 will be equal to 2 into 6 into 6 by 2 plus 2 into 6. So on simplification, you will going to get RBV will be equal to 12 kilonewton. Also, we know the sum of the vertical reaction acting upwards will be equal to the sum of the vertical reaction acting downwards. So RAV plus RBV will be equal to 2 into 6 plus 2. So that means 12 plus 2, which becomes 14. So 14 minus 12 will be equal to 2 kilonewton. Therefore, RAV will be equal to 2 kilonewton and RBV will be equal to 12 kilonewton. Now we are going to take up, this is the actual beam. So now we are going to consider only between A and B. So we have RAV will be 2 kilonewton and you have a 2 kilonewton per meter for a span of 4 meters. And we are not considering the load at the point B now, at this juncture in the beginning. So we have only one vertical reaction and 2 kilonewton per meter of UDL. First, we're going to consider initially. See how the behavior we're going to take place. This is the step by step to analyze this. So SF at A will be equal to plus 2 kilonewton, which is acting upwards. It's positive. Between A and B, what happens? SF will going to be plus 2 minus 4 into 2. So plus 2 minus 2 into 4 will be equal to minus 6 kilonewton. So SF drops from 2 kilonewton positive to the negative by minus 6 kilonewton at the point B when you are not considering the point load, which is RBV, which is equal to 12 kilonewton. Now we will going to consider the bending moment. Bending moment at the point A will be equal to 0 and the bending moment at the point B will be equal to plus 2 into 4 minus 2 into 4 into 4 by 2 will be equal to minus 8 kilonewton meter. So when you plot this, so here we are going to get at 0 and BM at the point B will be equal to 8 kilonewton meter. And we are not plotting this because as the shear force changing its sign, so we will going to get somewhere you're going to get the maximum positive bending moment. So that we will going to identify at the later stage once you analyze the beam completely. And then finally we're going to take up the maximum bending moment. Now for initially we will going to just plot that particular point, which is 8 kilonewton meter at the point B for the bending moment. So then we will going to consider the next point, the vertical reaction now. See what happens. SF at the point B will be equal to plus 2 minus 2 into 4 plus 12 because plus 2 which is acting upwards minus 2 into 4 which is acting downwards plus 12 because it is acting upwards. So 14 minus 8 will be equal to plus 6 kilonewton. So now the SF increases from minus 6 kilonewton to positive 6 kilonewton here at the point B due to the vertical load which is acting upwards. So then what happens to the bending moment diagram? The bending moment diagram will not going to change anything because we are just considering the upward reaction for the load at RBV, which is equal to 12 kilonewton. So the bending moment diagram will going to remain the same as the previous one. Now we will going to consider between B and C. We will not going to consider the point load at the point C, whether it is the vertical downward load of 2 kilonewton. We are not considering that. So when you're considering this SF at the point C, it will be plus 2. So that means plus 2 minus 2 into 4 plus 12. So that means you're going to have plus 6. Then minus 2 into 2, it becomes plus 2 kilonewton. So therefore, we can see the SF varies from plus 6 to plus 2 kilonewton because due to the uniformly distributed load, it varies from 6 kilonewton to 2 kilonewton at the point C. So what will going to be the bending moment at the point C now? So BM at C will be equal to then 2 into 6 minus 2 into 6 into 6 by 2 plus 12 into 2 will be equal to 0. So on simplification, it becomes 0. So therefore, bending moment at the point B, which was 8 kilonewton meter, then when it comes to C, it becomes 0. So join these two by means of a parabolic curve because it is a UDL. So what will going to be the maximum bending moment now? So because as the SF is changing its sign from positive to negative, so at that point you will going to get the maximum bending moment. So maximum bending moment will occur at a point where SF changes its sign. SF changes its sign at D and B now. So one point is at D and the other one is at B. Hence, the bending moment is maximum at points capital D and capital B. So when you're considering that, here, let D be the point at a B, let D be the point B at a x meters from A. So what is SF at D? SF at D will be equal to 0. So SF at D will be equal to 0 because the value of SF at that point D is equal to 0. So that is equal to plus 2 minus 2 into x equal to 0. So 2 into x will be equal to 2. Therefore, x is equal to 1 meters from A. So what will going to be the bending moment? Bending moment will going to be 2 into x minus 2 into x by 2. So plus 2 into x minus 2 into x by 2. So now you substitute the value of x as 1 meters now. So that is plus 2 into 1 minus 2 into 1 by 2. So that will be 1 kilonewton meter is the maximum bending moment at that point. So when you are plotting that, see what happens. When you are taking from here, so it rises to 1 kilonewton meter here at the point D, and then again it drops down to the negative value of 8 kilonewton meter. So this will going to be joined by means of a parabolic curve because between A and B, you have the uniformly distributed load. So in the bending moment, the power of x is 2. Therefore, you will going to join these 3 points by means of a smooth curve. So that means it's a parabolic curve. So when you see this here at the point E, the bending moment is changing from positive to negative. So you have the point of counterflexion. So before that, we want to identify which will going to be the positive bending moment and which will going to be the positive negative bending moment. So maximum positive bending moment will going to occur at the point D, wherein it will going to be plus 1 kilonewton meter. And the maximum negative bending moment is at the point E, which will going to be minus 8 kilonewton meter. So that is what, minus 8 kilonewton meter here. Now we will going to consider minus 8 kilonewton meter. So the bending moment varies according to the equation of parabola because the power of x is 2. So now we are going to take up the point of counterflexure where the bending moment changing its sign from positive to negative, that is from this point from positive to negative here. So this point is E. It is the point where the bending moment changes its sign. Let E be the point at a distance of y meters from A. So we are considering that point as y meters from A, that is from here. So when you are taking the section at the point A, see what happens. So bending moment at the point E. So what will be the magnitude of the bending moment at the point E? The bending moment at the point E, the magnitude of that will be equal to 0 because the bending moment is changing its sign from positive to negative. At this point, it is 0. So that will be equal to, so that means in other words, you are taking the section at this particular point with respect to y at the distance of y meters from A. So that means 2 into y minus 2 into y by 2. So that means 2 minus y will be equal to 0. Therefore, y will be equal to 2 meters. So the bending moment is changing its sign from positive to negative at a distance of 2 meters from A. So this is therefore the point of counterflexure is at 2 meters from A. So this is how you will be able to get the final solution wherein you have the x meters from A, there the bending moment is changing its sign, so the value of x will be equal to 1. And the point of counterflexure where it is going to change its sign, which is y is equal to 2 meters. And we have the maximum positive bending moment is 1 kilonewton meter at this point, which is D. And the maximum negative bending moment is occurs at this point, which is minus 8 kilonewton meter. So this is how you will be able to analyze and get the final solution. Thank you.